Welcome.
To the joy of coding.
Hello, hello everybody, and welcome to episode 32 of The Joy of Coding. Again, I never keep track. This is either 32 or 33. I'm gonna say probably uh, 33. This is episode 33 of The Joy of Coding. Hello, welcome. I'm Mike Conley. If you're wondering why I was doing this during the beginning, I'm pretty sure that there's something wrong with my setup and I'm playing sounds. Like normally I play sounds while I do stuff. Like
I don't think so.
they're really quiet and I don't know exactly why. Um, but they're pretty quiet and sorry about that. If you're here really looking forward to some good old wacky morning DJ sounds, I'm afraid they're going to be a little bit quiet today. Also, I'm in a sunbeam. There's like sun streaming through this window. It's the time of year where the sun is here at this time of day, and if I'm not positioned right, it gets right in my eyes. So you might see like a lot of bright stuff on my face whenever I switch over to my screen. And like I think there's like a little bit of this white stuff happening here is because of the sun as well. I wish I could bring down the shades more, but they're as down as they can be. So maybe I can move my camera a little bit to get rid of that white thing. Oh no, it's the wrong way. Here, if I move it this way, that might be a little bit better. Get rid of some of that white stuff that was over here. Although now you get a little bit of the leak over from behind my green screen. You know what? It's all details. It doesn't matter. Let's get started. Let's get started. Okay, so what are we doing today? This is the agenda. If you whoops, didn't mean to full screen that. If you are interested in following along, there's a link to this agenda down in the additional links section down below if you're watching this on Mozilla, and you can click on these links and follow along. And what I'm thinking, I'm hoping we can do today is I want to start with a bit of a warm up. So I've been watching a lot of Bob Ross. Bob Ross is like the joy of painting, which the joy of coding is like that's a reference to that. All of his videos recently went on to YouTube and Twitch and stuff. And I've been watching them and he's so relaxing to listen to and he sounds so good. And I want to try and work some of his calm zen uh, persona into the joy of coding as well. I'm gonna try it anyway. So I'm gonna try and not caffeinate so much. I've got water. I didn't have any Coke or coffee or anything like that. So I'm gonna try and make this a little bit more of a calmer experience today. And let me know if that's better. Let me know if you prefer that over the more active, sound-filled joy of coding experience. So we're gonna try calm today and see what that's like. Okay, so what are we going to start with? I'm thinking what would be best is if we start with a warm-up of some kind. There's like, I've got this bug that's not an M8 for electrolysis, but it's electrolysis related and it actually has to do with a test that was disabled. So let's take a look at this bug. What's this about? So we get a full rounded sense of what we're going to be doing here. So long ago is like a year ago, maybe even a little more than a year ago, I wrote a patch to fix a particular bug, and I wrote a test for that patch. But the test had to be disabled because there was other stuff that we needed in order for that test to actually run and work properly. And so that test just kind of stayed disabled. It worked for non-E10S, but it was disabled for E10S. And now, well, someone has realized that that thing that I depended on was enabled or was made available not too long after I had originally wrote the test. So they said, well, you should be able to turn this test on now. So they did, but then they found out a lot of the test is broken. So I think, and looking at the test, it's using like sort of some old techniques that there are better ways to do certain things now. So I'm thinking what I might try and do is rewrite that test for the first couple of minutes of this episode. Just as a warm up, we'll rewrite the test using some of the newer technologies and frameworks that we've built around testing with E10S. And then if there's anything actually broken here, well, we can file bugs for it. So, what is the test? Excuse me. The test is, let me actually update to central, the tip of central, and then build faster, and then we'll take a look at the test. The test is browser bug 1058164. So let's open that up next. And so I can see that this is using sort of older techniques, like preparing for page event is we're setting down sort of custom frame scripts down to the child process, and we've got better ways of doing a lot of this stuff now. I think we can really simplify this test, and I wonder if maybe simplifying it will actually make things make it pass. So let's try and find out. So this is under DOM base test. I'm going to open up the thing that we've put in to prevent it from running if eTNS is disabled. That's this. I will get rid of that skip command. So now we should be able to actually run the test. And let's confirm that it's actually failing. DOM tests. What was it? DOM tests base. DOM base test. And then browser bug. And then 1058 something or other with eTNS. And let's see what happens. Oh, now I've got, there's like all this stuff leaking over here. The sun is moving. That's why we're seeing more of that leakage. And so I'll move the camera again. But we're going to see it creep in more and more, I'm afraid. So this test did fail. I saw the failures that McCrate saw when he filed this bug. And it looks like timeouts and stuff. But I'm reasonably certain we're actually firing the events that we're waiting for here. So let's rewrite this test. What does this test do? Before we can rewrite it, we have to know what it does. And what it does is it opens a tab and selects it. And then it sends down a frame script that listens for the page show and page hide events, but only if the persisted property is true. And then what do? We swap the browser out to a new window, and then we wait for the window to load so we can get the selected browser to listen for. Prepare for page event. So we set up a tab, then we tear the tab out, and then we wait for hide and show events from the one that was torn out. And we also, I don't know why we don't just yield this directly. Wow, this could be better. And then we send the browser back to its original window. So we bring it back in, swap browse and close other. That's when we bring a tab into a pre-existing browser. Yield waiting for the page hide and show event promise. So we do it again for the browser that's going in. Okay. So I think we can rewrite a lot of this. And then what are we doing for this timeout occurs whenever we're waiting for the page show and page hide events to come from the child. Alright. Well, the good news is we're already using add task. That's a good start. Oh, here's a good, I put in a description for the test. That's good. Tests that frame scripts get page show and page hide events when swapping browser frame loaders, which occurs when moving a tab into a different window. Okay. So I'm going to rewrite this test. What I'll do, actually I kind of like what we've already got here with adding the tab, selecting the tab. Now this stuff with the frame script we don't actually need anymore. What we probably should do is rewrite some of this. We've got this like prepare for page hide and show. And that should probably occur Like, we should probably do that preparation before we do the tear out. So prepare for page hide and show. Prepare for page event. So what I'm thinking is prepare for page hide and show will return a content task dot spawn. Content task dot spawn returns a promise. And what it'll do is that promise will resolve. Prepare for page hide and show. So what I'm thinking is these two events could happen at different times, and there should be two individual promises for each, and then we can return whenever both promises resolve, which is kind of like what we were doing in this method before, but we're gonna end up skipping a lot of this stuff up here if we use this technique. So what we're going to do is let page show promise equal new promise resolve, and let page hide promise equals new promise resolve, and then return promise dot all page show promise page hide promise. And then what we'll do is inside here add event listener page show function we'll call on page show event, and then it'll, if event dot persisted, then we will remove event listener page show on page show, and then we will resolve. And then it's the same thing for page hide actually. So it's a little repetition, but it's not so bad. One of the trade-offs I've always found, like sometimes you work really, really hard to remove repetition and redundancy, but what you end up with is something so general, so generic that it's very hard to follow. And in the end, yes, it's nice to remove a lot of redundancy, but you can go too far sometimes, I find. And I think this is readable and reasonably readable and understandable. So what's going to happen is when we call this function for this browser, we're going to send a message down that sets up these two promises in the content promise, and then resolves whenever these two promises resolve, which occurs whenever page show and page hide both come in with event.persisted. So now what we can do is wait for load. So this, I guess what we want to do is make sure that we get the page hide and page show events both on the tab whenever it's torn out, and then whenever it's splatted back down. I think that's what we want to do. Whenever it's torn out. No, that's not true. We should only get a page hide and a page show once. It's not like page hide, page show, swap out, page hide, page show. It should just be page hide, page show once per tear out. And I understand, because like we need to make sure that the selected browser is going to fire that. Okay. Replace tab with window, and then wait for load on the window. Yeah, let's try that. Yield. Send the browser back to its original window. Swap browsers and close other. Alright. Wait for load. So I think we can get rid of a lot of this stuff now. Let's see what happens when we run this test now. Oh boy, yeah, you can really see the the sun creeping across. I don't know what I can do about that. I think next time I'll just have to make sure I don't sit here. That's probably our best bet. Because I don't think I can... There's not much I can do to defeat the sun here. So this test is hanging now, or it's yielding, and I'm not sure what it's waiting for. So let's add some dump statements. Wait for loading, waiting for load of new window, and then waiting for page show, page hide. If I had to guess, I'd say it was those events. Dump, got the events. I'd say it's probably those last two. The page show, page hide events aren't firing, or we don't see them firing. Waiting for load. Yeah, waiting for page show, page hide, and then we do nothing. So we never see them? Saw page show. Dump. Saw page hide. Whoop. Don't be afraid of using dump statements. Sometimes that's the way to an answer. Yeah, we're not seeing those events. Maybe they happen before. I wonder if it would help if we were using like tabs with content. Is it possible that by the time we hear this load event, the page show and page hide events have already fired? We can find out. I remember where the page show and page hide events were added. And that's in swap with other loader in NSFrame loader. And so I can attach my debugger and see if we get there. So what I'll do is no auto run. And find out what this process is. CPU time. I need nightly. I've got two nightlies here, and I'll take the shorter one. This one, 68902. And this is the one where I will set a breakpoint. Yeah, I got the right window. Set a breakpoint, and then it's in nsFrameLoader.cpp, and then swap frame swap remote loader, swap remote browser, I think is where it occurs. Where did I fire page show events? Swap with other loader, swap with other loader. And that's going to fire the page show and page hide events. Swap with other remote loader though. What? Hmm. 1095 is here. Swap with other loader, like that's dispatch the content scripts when swapping frame loaders. When we drag a tab out to a new window, we swap frame loaders with the new window. The page show event gets fired because we're pulling the page out of the BF cache. Unfortunately, content scripts for the frame loader don't seem to hit the page show event. A look at this frame loader shows that we're dispatching those events to the Chrome event handler, which bypasses content scripts on the frame loader. That we dispatch the events to the parent targets of each window instead. Presumably this bug applies to page hide, so both should be fixed in tandem. Oh. Is it possible that the reason that this test is not passing is because we do not fire page show and page hide events whenever things are swapped in the content process? Because when we swap a remote loader, swap with other remote loader, we don't fire any events in here, but we send a message down to the browser, tab child, swapped with other remote loader. Then we are, okay, we do fire a page show, page hide, and then page show event. So we should be firing these events. Well, I can find out. I can attach a breakpoint to the web content. If I can get the web content to show. Okay. So that should have loaded some web content. And that's process 68927. And what I'll do is I will break and set a breakpoint here. I'm pretty certain we're going to hit this. But maybe not. Maybe this test is not testing things properly. That's an unrelated breakpoint. Yeah. Yeah, we're in the right place. We fire those events. And then we fire them for the other one that we're swapping in, or we swap. Okay, so we are actually firing those events, so that's good news. But I'll bet you if we were to look at the order of events in the log. Like maybe I can run that test again without having to. So yeah, I'm about to fire this with a, and I haven't actually said waiting for load of the window yet. Like, let me keep going. Hmm. Wait, no, I'm wrong. Here, let's try it one more time. So we're waiting for the page show and page hide events. So we are waiting for them, and then we are firing these events. Oh, but they're Chrome level. They're Chrome level events. Okay. I think I have to modify this test a little bit. Page show. Well, first of all, does this ever work? Page show event handlers. Oh man, alright, I need to re-familiarize myself with all of this. And I've got this sun in my face. This is all bad. But Bob Ross would not complain. Bob Ross would say, that sun in my face, that's nice. It's nice and warm. I'm feeling the warmth. Feeling the warmth of the of nature on my face. So my question is, do we ever see the page show or page hide event with multi-process Firefox? Have we been broken here for a while? So let's see, content, where did I put that stuff? Page visibility. So we do hear messages about page show and page hide. Now how about whenever I tear out a tab? Or tear in a tab, I should say. So let's new window, and we'll take it to watch people code. And I'm going to tear this tab in. We do hear an event, this page visibility show event. Okay, so they are working. I also have this doesn't go away. That's annoying. To make sure that the new Windows selected browser is going to fire these events. It is the right browser. And we're not seeing either of these. Page show, page hide. And yet I don't think we're doing anything special in Content.js for listening for page show. No. Here. Saw page show event. MBF, that's mock build faster. I have an alias for that. Let's try this again. Have a quick sip of water. So I will try and make sure that next week I'm not in a place where there's so much sunlight. Yeah, saw page show events all over the place. And this is after we're waiting for page show and page hide. So something's wrong here. Okay, theory. This stuff isn't even running. Let's find out. Am I running? That's just a sanity test. Because if that stuff's not running, that would explain it. Am I running? It is running. So am I running at the right time in here? Adding page show event listener. Let's try it again. Yeah, the event listener has been added at the right time. What's the dealio? Okay, here's an experiment. Theory. I'm seeing page show events, but they're not firing on the same browser. They're not firing on the browser that I expect them to. Page visibility. So if we see message dot target dot set attribute sent page show true. So anything that sends page show, I'll set an attribute on it, and then in here what will I do? I guess what I'll do is I'll manually check to see whether or not the torn out window, or which one do we care about? In this case, yeah, the torn out window browser has that attribute. So I'll use the JS debugger argument so that I get my toolbox. Ooh, if I position my head here, it's perfect. This is perfect. Okay, I wanted to set a breakpoint. No, I didn't want to set a breakpoint. I wanted to run the test. And then choose the right window. Right, so now I have to choose the right window. Which one is it? It'd probably be the second one, actually, because as you increase the number of windows, they tend to move in. So no, that's not working. My inspect tool won't work. But what I could do is open up the browser console. Yeah, gbrowser, selected browser. Ha! So it doesn't have the attribute, but this old one, does it? G browser, selected browser. Sent. It doesn't. Hua? Hua? We have a mystery on our hands. Okay. Hold on. Let's get a grip. Get a grip here. I've got two event handlers. There's one. So, like, I'm supposed to be getting this message because I am firing up. I am seeing page show events. But am I sending up this message? And is this receiving the message? Page visibility. Show message. And then content says sending page visibility show message. Hey, we're gonna get through this. When things look odd, don't worry. You'll get through it. You just keep pushing. So yeah, we do see these page visibility show event things. So then how come nobody has our attribute that we've been putting on things? This sent page show attribute. Hmm? That just failed explosively. Sent. Maybe there's get attribute sent page show. Oh, it's just not showing it to me. Lovely. Lovely. So, let's run the test. And now, selected browser, get attribute, sent page show. So this one is also sent a page show. Or we saw a page show. So what does this all mean? What lessons am I getting from all of this? I don't know yet. It's almost like I've done everything right, and yet these events are not being seen ever. Page show, page hide. Now why would that be? Are the events being stopped? Maybe we should capture them. Let's try capturing them. See what that's like. Okay, so we can get rid of that. We can get rid of this. Capturing didn't help. Content should be implied. shouldn't need that. So this warm-up is ending up being more complicated than I thought it would be. Which, I mean, that happens. Let's see if this would work just in general for browsing around. Like, let's see if this works if I were to change this test from opening up a new window to just doing something normal, like let's browse a tab from one page to another page. So let tab equal gbrowser, add tab, and then let browser, gbrowser selected tab equals tab, and then let browser equal tab.linked browser. And then we'll set up our listener, or our promise. So let promise equal prepare for page hide and show. And then we'll move the browser to a different page. What's a good page to send it to? We have lots of like example HTML pages that we send things to, like example.com internally, or even better, these actually that have pages. So browser.load URI, and then yield the promise. So do we ever, what happens if we do this? Do we ever show the page show and hide events? Just for browsing along? Interesting. Oh, yes, saw page show, saw page hide, saw page show. And yet, what are we waiting for? Yield promise, saw page show, persisted. Oh, that means we have to come back. Okay. So load URI, yield browser test utils, browser loaded, browser, and then browser.load URI, and then let's load another page. We'll load this page. Yield browser test utils, browser loaded, and then that's when we'll set up our promise after it's loaded, because we're going to go back, and we'll say browser.goback yield promise. And that works. Oh, it doesn't work. Oh, it worked, but we're not actually testing a thing, and we left our tab around. So what this tells me is that in theory this should work properly, but we're, I think, dispatching our page show and page hide events differently. Like, as content utils. Let's take a look at this. Content utils, CPP. Fire for given document is showing returns the same as if fire if showing. Let's give us away to fire page only on documents are still loading. So we pass the Chrome event handler is the second argument. and the Chrome event handler is our event target, which is our Windows parent target. I don't know if that is useful or not. But we fire the page show event. What else uses content utils fire page show event? Well, maybe we're doing it in a special way. Like, because whenever a fire page show event, doc on page show, Chrome event handler, on page show. I think that's important. Jump to definition. Jump, find declarations of this. Here we go, on the document. Whew. DXR, come on. There any brightness stuff happening behind me? A little bit. Dispatch. Page transition, page show. Target. Target, we get the event. Start target. Page transition. Then we dispatch the DOM event. Huh. So it looks like we're doing the right thing. I'm going to do some more sanity checking. I'm going to get rid of all this stuff that proved whether or not our function should, in theory, work. Only pay attention for page show events after this. So any of the sort of loading up page show events, I don't care. It's only the page show events. Dump. Content saw page show event. Okay. Sometimes bugs that you thought were going to be simple end up being more complicated. And that's okay. That's reality. Oh. Exception thrown on line 84. I think I did something wrong. Yes. That's not going to work. Let's try that again. Version 42 of Firefox came out yesterday. I mean, it's pretty awesome. So we do see page show events at the right time. Yeah, I was worried about that. Am I... Sanity check here. Page show event. I've got the format right. Name of the event and then a function. There's this like other argument that you can pass to the event handlers that like only Mozilla code pays attention to. I'm just gonna double check that that's not. It's for like whether or not we allow untrusted events. I'm feeling that's not what we want. Yeah, that's not what we wanted. Hmm. Hmm. I'm thinking of making it so that the tab that we open has a script that has a page show and page hide event listener, just to make sure that we're seeing events on the right things. Data, text, HTML, script, add event listener, page show, function, E, dump, saw, the tab saw, page show event, and then yield, browser, test utils, browser loaded, tabbed unlinked browser. The tab saw the page show event, and then content sees page show event. Aha! Aha! Wait. The page finishes loading, and then the tab sees the page show event. The content sees the page show event. And then we... So we're setting up our page show and page hide events too late, it says. Event handlers too late. That's why we're not seeing them. We're too late. Too late. So maybe instead of on browser here, I have another idea. New window. Wait for new window. Delayed startup. DOM windowed opened. This DOM window opened. So instead of waiting for the window to load, let's yield browser test utils DOM window opened. let the win equal the DOM window being opened. Or wait, no, hold on. Wait, prepare. Replace tab with window. Maybe that's what we should do, because we get it back right away. Promise we'll prepare here. We'll wait for it to load. Or we don't even have to wait for it to load. We'll just wait for the promise here. Does that make sense? Missing something. Oh, yeah, it's bad syntax. So let's simplify this a bit. Get rid of that. Do we have to wait for the window to load to get the selected browser? Gbrowser's undefined, so that's why you have to wait for the window to load. Wait for the DOM to load. So we did have to do that. We do have to wait for it to load. And only then will we have Gbrowser and the selected browser. But by that time, page show will have already fired. Content saw page show event, and then we wait. How does replace tab with window work? You open up a new window with a browser in it. Maybe that's what I need to look at. How does replace tab with window work? I feel like I've done this before. We open up a new browser window and we pass tab as an argument. We pass the tab as an argument. We wait for the new window to load. So, hold up. I think I can do more. Printf child saw swapping frame loaders, firing page show and page hide. Okay. Mock build binaries. Because I updated some C++. What's happening here? The sunbeam is... The sun has moved. I wonder if... No, I can't really do much. Alright. Maybe this will give us a sense of what's going on. Above all, do not panic. We appear to be doing the right thing. Replace tab with window. We wait for the load of the new window. Then we wait for the page show and page hide events. Hmm. So what's the deal? Again, I don't understand. The child sees the swapping of the frame loaders and it fires them. And yet, neither of these event listeners see it. Have we passed in the wrong browser? Hmm. Set interval. Every second. Dump whether or not. New window, G browser, selected browser, dot get attribute, sent page show. That's pretty sloppy. But what I'll do is I'll put this thing back. I don't understand why we're not seeing the event being fired, and I'm wondering if maybe for some reason we're attaching to the wrong browser. The browser well, it reports that a page show event did go through that new browser. Add event listener. What is happening? So that's another just stab in the dark. No, we don't see it. We do not see it. What about content doc content dot add event listener? That should be implicit. Content. That should be implicit. That should not be required. Content is null. Wait, what? Content is null. Am I using content task wrong? Uh, no, we. You know what? Let's. This is gonna sound crazy. I'm gonna copy this stuff over, but in the interests of like doing other things, I'm actually going to revert. I'm gonna revert everything I've done and go right back to the beginning. Because this code apparently um, this test will work with non-E10S because it's enabled for non-E10S. So let's run it without it. That works. All right. So sorry, someone's just R-minusing a patch for me for good reason. And other stuff's happening. This is a mystery. You know what? This is bigger than I wanted it to be. I am going to start a note on this. And the mystery, I'm going to write down the mystery, seems to be that the content scripts that I'm sending down to the browser that gets opened do not end up receiving the page show or page hide events. I'm going to move that, sorry, out of here into active bugs. And you know what? I'm going to put a halt on this. What was supposed to be a relaxing warm-up of rewriting a test ended up being sort of a rat's nest. Sorry about that. So what did I want to work on today? What was it that I actually wanted to do? There's this other bug where I don't want to use kapows whenever windows close. So with Session Store, I need to go Bob Ross. Why did we abandon that other bug just now? It's because I ended up taking too much time on it. Like we were really ended up seeing something that I don't fully understand and will require some more investigation. And I feel like it's not worth the time right now to do that investigation at this time. Maybe in a couple of days when my M8s kind of get cleared up, because this other bug that I want to work on is an M8, and I should be working on this. And I only wanted to do the other one as a warm-up to just kind of like accomplish something. And that's exactly what didn't happen. It didn't happen. So let's talk about this other bug. Now we've only got about 20 minutes or so before I feel like I'm going to shut down. So let's see where we can get. Um, let's see. What do I want to talk about? Session Store. So what goes on whenever you close a window? Suppose you have a window with lots of tabs in it, and you close that window. Because with E10S, the communication with the tab content is asynchronous, it's possible that Session Store in the parent doesn't have like the most up-to-date information about those tabs, like the form history or your scroll position, or even like, well, those are probably those are the two that come to mind anyways. Scroll position, form history, and whatnot. And so what we do in Session Store is when the window is closed, we send a synchronous message down to the child saying, hey, give me your most recent information. Give me the last stuff you've got before I shut you down. And that uses a kapow, and we don't want to use kapows anymore. So it's the good news is we can send a message, an asynchronous message down to the child saying, give me all of your last bits of information. Send me your most recent messages or your queued messages, and we'll get those in the parent even after the windows may be gone. Maybe the frame loaders have completely gone away, but we still hold a reference until the unload event handler is fired in the content for the remote browser, and that's handy. That's how our async tab closing stuff works for Session Store as well. We used to use kapows every time you would close a tab, and so oftentimes you would see jank or sometimes even full-blown browser hangs due to like a kapow deadlock when closing tabs, and we were able to get rid of those. And we want to do the same thing with window closing, because you can sort of get into the same trouble with window closing with these sync messages. And I've sort of got a strategy on how I want to approach fixing this bug. And I think I'm going to go, I outlined 3 solutions. So here's the method that runs when a window is closed. Here's the sync method that's fired that sends a kapow message down to the child and blocks the parent until all the sync stuff has come back up from the or all of the messages have come back up from the child. And then we do all this like other stuff that depends on the window still being around. So here's the challenge. If we do this asynchronously, we're going to exit the on-close event handler in Session Store while we're waiting for messages from the child, and then the window is actually going to close. And some of this other code depends on that window still being open. So what we need to do is make sure that we collect the information that we need from the window before it closes in this on-close event handler, but that we're also able to sort of join it up with the asynchronous stuff that comes up from the child whenever it's ready. And I've already done some of the groundwork where I've added a couple of methods there's something called tab state flusher, and what it will do is if we call flush window on it, it will return a promise that resolves when all of the tabs in the the browser tabs have been flushed. So that means we've sent a message down to all of them saying, give me all your data. Give me all your queued messages. And so when all of those resolve, then the flush window method will resolve as well. And then what we can do, I think, is then update all of the tab data once that promise is resolved, and then we should be good. One thing about this solution that's kind of annoying is that we end up collecting tab data twice. So this collect window data stuff, there's this method called collect window data that's actually going to go through each of the tabs and collect all the tab state, which will be out of date. That's synchronous, and that's fine, because the tab state is what the parent, it's like a cache of what the parent has heard from the child about each tab. And then we're going to send this message down saying, give me your latest stuff. And then when it's all done, we're going to rewrite into the tabs data for the window, and And so we'll end up doing this tabs data thing twice, which isn't amazing, but it's simple. It's a lot simpler than it could be. There's a number of other solutions I came up with that are a little more complicated, and I really don't want to go down that route. Sorry, my pocket is buzzing like crazy. People are talking to me. So I'm going to go with this collecting of tab data twice. And let's see what we can get done. Let's see what we can do here. So on close, a lot of this stuff we want to occur synchronously, but not this business. We don't want the tab state flush thing to happen. But we will collect the window data. Grab the most recent window data. We'll update the tab data after we're done flushing all of the window tabs for this window. Tab data again. So then we get all of this stuff. And then we don't want to do this stuff until we've done the flush. And we also don't want to do this either, removing the messages. We need these messages. We don't want to delete. Okay, so there's this like cleanup work that has to occur. Let clean up. So some of this we can do right away, because if we're not in the running state, we don't have to do this asynchronously. Let cleanup window equal I'm gonna have this helper function that will do this cleaning up. Actually, the dying cache win data. Where's win data? Win data. So we're going to end up writing back into the win data. Okay. This is the stuff I think we should do maybe after. Else clean up window. And this needs to happen after the async stuff. Let's collect window data. So something like tab state flusher flush window a window, then we are going to update the tab data now that we've got the most recent information. So we can do like, well, what does collect window data do? Collect window data. It's basically, we're going to be duping this win data.tabs. Yeah. Tab state flusher dot flush window is what we used. except how do we do that? Tab state collect tab. That's hard because the tabs have all gone away. Tab state collect takes a tab and a browser. Are we gonna have to like hold on to these tab nodes? We might have to. We might have to like hold on to them in a closure. Tab browser. Tabs equals G browser. Tab browser dot tabs. So that will keep it alive inside the closure. And then we'll collect each one. Tabs data dot push. And then WinData dot tabs. Yeah, okay. WinData, which we already have a reference to. Okay, flush window. So this is very sloppy, but this might work. I'm curious to know if this will work. This is let's give this a shot. No guarantees. That could be very wrong. But I'm looking for a win here. I need a win. Okay, so let's open up a new window. And then I'm going to close this window. Recently closed window. Hey. I don't know where this other window came from, but okay. Recently closed window. Okay, so that's good. I'm not using a kapow anymore. And then if I recently... Cool. And browser console is not complaining about anything. I'm tentatively, this is encouraging. We seem to be doing an okay job getting this state asynchronously. I'm curious to know what tests might have been completely destroyed by this, though. Let's find out. Because we've changed an assumption. We should also make sure that, like, the... Here, I want to... Whoa, 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 whoa. So that's wrong. Look at all that. That's all wrong. So there's a bug. The fact that these windows have gone away... I wonder if, like... This is never running? Is it possible that this is never running? Let's find out. Session store.jsm flush window. No, we're not. We're not firing it. Oh shoot. That's not good. So that explains why, that explains that problem. So let's create a new window, and let's step through what's going wrong here. So we say, flush the window. Promise that will resolve. Update. Receive an update on a flush. With the browser gone, I don't think we ever fire that update message. Flush the window. Oh, here we go. Frame loader. Owner element is Azul browser. And at this point, the parent should be gone. Parent element is a browser stack. Frame loader. I want to know if it's like been destroyed. Visible is true. Well, even so, we didn't get the right flush ID, I don't think. Here. Let's do this again. Flush ID. So we asked to flush the window. And the message data flush ID is 17. And I also saw this operation not possible on dead kapow. Let's do this again. On close. Tab state flusher. JSM. Flush window. And then flush. Okay, so. So we're going to say flush the window. And yes, flush. And the ID, the flush ID is 19. That's the message that we're sending down. And then we never get a response. The hell? So there's a problem. I'm unreliably the update message after the flush seems to be pretty unreliable. It doesn't look as if I'm getting, as if we're holding the frame loaders alive until those messages come up. So that's an interesting problem. And you know what? We're going to look into it, or I'm going to look into it. But not right now. I think I'm going to call this episode. This episode was a little bit calmer, a little more gentle. There's a lot of sunlight. And it's a little quieter, a little less sound effects. And I want to know what you thought about that. Like, was today a little more boring, a little calmer, a little more frustrating? Let me know. I'm curious to know. Maybe you want more activity. Maybe you want more hand waving, or maybe you want sort of like more relaxed Bob Ross style commentary. Let me know what you want, and I will do my best to deliver. And I know we didn't fix any bugs today, but we're getting down into the really weird ones, so that's why. Okay, I'm gonna call it. Thank you so much for watching episode 33 of The Joy of Coding. Today was November 4th, and I also want to point out that you can subscribe to The Joy of Coding on iTunes or Kodi. If you use either of those applications, you can subscribe to a feed so you never miss another episode. There's a link to the feed that you can subscribe to in the agenda down below. Thank you so much for watching The Joy of Coding episode 33, and I will see you next week. Bye-bye.